So let's say you're designing a junction in a CLT, cross-laminated timber building between dwellings. Which flanking transmission or transmission paths in general do you need to consider? We'll take a look at it. If you have a junction, something like this, we have to do, yeah, that's a good one. Let's do a simplified model, something like that. So the most obvious one, of course, would be the direct transmission. That, let's say you have apartment 1, apartment 1 here and apartment 2 here, and we're gonna consider the vertical sound transmission. So the obvious one would be here, direct. And usually this is the largest separating area, so it's kind of natural that this one will dominate. But you also need to consider flanking transmission, and then of course the most intuitive one to think about will be this one. And then you have to consider how you're gonna design this junction. Should you perhaps put some elastic interlayer here, or you could put both upside and here and here. And let's talk about that a bit later. So here's 2 of them, but that's not all, because sound can also go like this. It goes into the floor and out through the wall down here. It's a bit strange look on that. I didn't like it. So here's another flanking transmission path that you must think about. And it doesn't end there either, because it can also go this way and come out through the ceiling. So as you see here, you got quite a lot of transmission paths. Now, depending on what kind of acoustic solution that you go for here, this will have various implications. So let's say one common design is that you use perhaps an installation floor, one of these where the floor is standing on little pillars like this, and the pillars they usually have up here or down here some kind of vibration isolation. Now this solution improves, and there should also be, of course, mineral wool in the cavity. This solution will be good in the vertical direction. It will also be good in this direction, because it will take care of this path, but it doesn't do anything for these 2 paths. So here you need some other kind of solution. And one obvious choice could be to put, like I mentioned before, an elastic interlayer up here. And then you can take care of both of them, depending on what quality you use on this layer. And if you would choose another one, you could perhaps go with 2 thinner ones. Typical would be like 2 × 6 millimeter, both up and down. And that would improve not only this one, but also the one that goes through here. However, with the installation floor, that might not be a really big issue. So it could work with either one, up here only or on both sides. But depending on what kind of construction you have up here, this one can be important as well. And also another thing, when you have 2 of these separations with the elastic interlayers, it's 2 junctions that the sound must pass through, and I have a feeling that you lose quite a lot with this dual damping like this. However, when you think about it, let's say that you go for a single one. Let's see if I can erase backward like this. When you have the dual 6 millimeters, this one, then this path looks like perhaps could be one of the weakest links, because now we have 6mm up here and you have 6mm down here. So this path goes through 2 elastic interlayers. This one only goes through 1. So if you put 1/12 instead up here, then both of these transmission paths have to pass through 12mm of elastic interlayers. And there's a lot of custom work involved with this, that you have to, every building project is unique. And you cannot just say that there's a one-size-fits-all approach here, because now we've only considered like one installation floor here. But there are so many other options remaining that you also need to consider. I mean, you could put here some... That's a topic for another video. Let's do it some other time. But what happens if you put a suspended ceiling on this side? Elastic connection like that. Or if you do something with a wall here. If you add a second layer here with some mineral wool like that. It affects all of these transmission paths. And it goes in all directions. And it's also 3-dimensional. So it takes some time to get used to the thinking with acoustics. So it's a deep rabbit hole. You can easily consider it like that. It goes very far. As soon as you start to think about how many various and different transmission paths there really are, you understand that there's quite a lot of optimization to do here. So we're not going to be running out of problems anytime soon. But that's also something that I really like with working with timber. It's so fun to tackle these problems and optimizing and figuring out. And sometimes when you think, yeah, I got the solution, and then you suddenly realize, oh, wait a minute, this transmission path, I did not remember to consider that one, perhaps. So there's also an element of gut feeling when you're an acoustician, I'd say. It's just like when you try to write in words how to dance or how to play tennis or how to play a musical instrument. It's really difficult. There's a bit of gut feeling involved as well. And I honestly think that acoustics is a bit like that too. You can calculate, you can use formulas, you can use equations, and you can use theory, but it will not get you all the way. You have to trust your gut and your ears as well. So, in today's video, I'm wearing pretty much the same linen shirt that I did yesterday, but it's so nice for the very warm weather that we have. So, I really like it. Light blue, we can talk about the color. Light blue color on the shirt is very versatile. Highly recommended. So if you're only gonna get 1 or 2 shirts, you should have one white and one that is light blue, and that will work with just about anything. So that's the staple piece that you need to have in your wardrobe. A white and a blue one, I'd say. Have a nice weekend. See ya.